Hello everyone, here I'm doing exercise 9.56 question. I have already done first, second, third and fourth, even fifth question in my previous videos. You'll get them from my channel. And here we go. So the sixth question is, using identity, evaluate all these problems. We have around 9 problems to do it. Let's start with the first question. So they are not asking us to multiply directly. We don't have to multiply 71 into 71 directly. Instead, they're asking us to use identities. So the 71, we can write it as 70 plus 1, right? 70 plus 1 and then whole square. Okay, so it's like a plus b whole square. This is a and this is b, and like a plus b whole square is there. So but we know that a plus b whole square is nothing but it's a square plus 2ab plus b square. Now here in place of a, we're going to take 70. In place of b, we're going to take 1. So from here we can write down this is equal to 70 square plus 2 into 70 into 1 plus 1 square. So this is equal to, when you multiply 70 into 70, we'll get 4900 plus 140 plus 1. This is equal to 5041. This is the answer for the first question. Now we'll move on to the second one. Now in the second question we have a 99. So 99 can be written as 100 minus 1. See, even we can write down 90 plus 9 also. The thing is, I'm taking 100 minus 1 because it is easy to calculate 100 square and all. That's why. So here we're going to use a minus b whole square. Okay, so it is equal to a square minus 2ab plus b square, where the a value we're going to take it as 100 and the b value will be equal to 1. We don't take minus 1, we're taking 1. So this is equal to 100 square minus 2 into 100 into 1 plus 1. So this is equal to 10,000 plus, sorry, it's minus 200 plus 1. So when you solve it, we'll get this is equal to 9801. So this is the second answer. Now we'll move on to third one. So third question is 100 plus 102. So we can write it as 100 plus 2. So 102 square can be written as 100 plus 2 whole square. So again it's like a plus b whole square, where your a value will be equal to 100 and b value will be equal to 2. Okay, we'll substitute this. So this is equal to 100 square plus 2 into 100 into 2 plus 2 square. We're just taking a and b value and substituting there. So 100 square is again 10,000 plus 400 plus 4. So this is equal to 10,404. So this is a third one. Now we'll move on to the fourth one. Okay, the fourth question is 998 square. So this is like 1000 minus 2 whole square. Now again we're going to use a minus b whole square identity, where a value will be equal to 1000 and b value will be equal to 2. So here a value will take 1000 and b value will be equal to 2. Now we'll substitute in this identity. So we'll get 1000 square minus 2 into 1000 into 2 plus 2 square. Now when you take a square of 1000, you'll get total 6 zeros and minus 4000 plus 4. When you solve it, you will get this is equal to 996004. Okay, it's like 9,96,004. Okay, that was about the fourth question. Now the fifth one is, we have 5.2 square let's write down. So fifth question is 5.2 whole square. So 5.2 can be written as 5 plus 0.2, okay, square, where we're going to take a as a 5 and b is equal to 0.2, and we're going to use again same identity, a plus b whole square is equal to a square plus 2ab plus b square. Now this is equal to 5 square plus 2 into 5 into 0.2 plus 0.2 whole square. Now this is equal to 25, plus when you multiply them, you will 5 into 2 into 0.2 will get answer equal to 2, plus 0.2 whole square is 0.04, and when we add all this value we will get 27.04. So this is the answer for the fifth problem. Now we will go to the next one, sixth problem. Okay, now sixth one is a little different one. So we have 297 multiplied by 303. So this can be written as, see, we cannot apply something like a plus b whole square or a minus b whole square because it's not given square, but we can write like this. It's like a 300 minus 3 into 300 plus 3. Now for this we're going to use a third identity, that is a plus b into a minus b is equal to a square minus b square. Here the a value is 300 and b value is equal to 3. So we got a and b value, you have to just substitute it. So this is equal to 300 square minus 3 square. So 300 square will be 90,000 minus 3 square is 9. When we subtract it, we'll get 39,991. Okay, that is interesting one. We have used different identity for the sixth one. Now we'll go to the seventh question. Now seventh question also the same thing. We have to use the same identity. Okay, it's a 78 multiplied by 82. So I guess you can able to understand why we're taking third identity. So here we can write 78 as 80 minus 2, and we can write 82 as 80 plus 2. So you can see it's like a plus b into a minus b, right? So a plus b into a minus b is equal to a square minus b square. Now you have to identify what is a value and what is b value. So a value is 80 and b value is 2. So a is 80 and b value is equal to 2. Now we're going to substitute the values here. So 80 square minus 2 square. So 80 square is equal to, we'll get 6400 minus 2 square is equal to 4. So when we subtract it, we get 6396. Okay, this was seventh one. Now we'll go to the next question. It's a eighth question. Now eighth question is different than this. Okay, so eighth one is 8.9 whole square, but we know we can write 8.9 as a 10 minus 1.1. I can write this as 9 minus also, but I've taken 10 because it is easy to calculate. Now we're going to use a minus b whole square identity because it's a minus sign and we have a square also. So a minus b whole square is a square minus 2ab plus b square. Now here a value is equal to 10 and b value is equal to 1.1. Now we'll substitute here. So we'll get 10 square minus 2 into 10 into 1.1 plus 1.1 square. Now 10 square is 100 minus, when you multiply 2 into 10 into 1.1, we'll get equal to 22 plus 1.1 square is 1.21. So when we solve all this, we'll get 79.21. Okay, now with this we're done with 8th question. Now your last question, which is the 9th one. Now 9th question is a little different than the other problems. Okay, here we go. So the question is 1.05 multiplied by 9.5. Now here we cannot write this, like we cannot apply any of the identity, but we can write 1.05 as 1 plus 0.05 into, and we can write 9.5 as 10 minus 0.5. Now you can see here we cannot apply any of the identity because we cannot apply a plus b whole square, a minus b whole square. Even we cannot apply third identity because we want a plus b and a minus b. But here each term is different. So we'll just multiply the binomial, both the binomials. That's it. So when you're doing it, multiply 1 with the entire binomial and then multiply 0.05 the entire thing. So when you do it, you will get in this way. So this is equal to 1 into 10 minus 0.5 then plus 0.05 multiplied by 10 minus 0.5. Now we're gonna just multiply with 1, so we'll get 10 minus 0.5 back, and then when you multiply 0.05 with 10, we'll get 0.5 minus, so 0.05 into 0.5 will be 0.025. Okay, now when you solve all this, you can cancel minus 0.5 and plus 0.5 and we'll end up with 9.975. When you subtract 10 and 0.025, we'll get 9.975. So that's it. This is the answer for this problem. I hope you have understood all the problems, how we are applying the identities. If you have any question or doubt, you can leave a comment below. And that's it. Thank you so much for watching. If you like this video, then subscribe and click on bell icon.